All right. Hi again, Algebra. Coming back at you. Thanks for the round of applause. All right. Here again from my living room. Welcome. Okay. So just so you know, what we're working on today, we have in fact done before as well. I said that this whole week would pretty much be a review because it's been a while since I've seen you. So you might have forgotten all this stuff. If you will recall, this exact one is the video in which I forgot how to do math. And I think we watched that little part of it in class after I taught it to you in person. So it should bring back some lovely memories for you, but I assure you, I have my trusty calculator with me today. Okay, so this is graphing quadratic functions from standard form. Standard form, I'm just going to cross out f of x, put y. Remember that is ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is just your constant afterwards. All right, so we can use this equation to find a whole bunch of different things, such as whether the parabola opens up or down. Remember whether it was a happy parabola or a sad parabola. All right, we can also use it to find the axis of symmetry. And remember, that's the line on which you can take the parabola, fold itself, and it would be a mirror image of itself on both sides. You can find the vertex, and the axis of symmetry actually goes into finding the vertex. So remember, the axis of symmetry is actually the x value of the vertex. And then you can also use it to find the y-intercept. We can also use it to find the roots or the zeros, the x-intercepts, the solutions, but we're not going to do that part of it today. All right, so on this graph, let's identify each of these. So this right here, of course, is pointing to the y-intercept. Again, just where it crosses the y-axis. This here is pointing to the vertex. And this here is pointing to the axis of symmetry. And that line is red and dashed here because it's not part of the graph. So it's just like that. Again, the axis of symmetry is always a vertical line. And it always has the equation x equals a number, right? So in this instance, 1, 2, 3, this is the line x equals 3. And x equals 3 also happens to be the x value of the vertex, right? So 1, 2, 3, 4, 5, 6. So the vertex is 3, -6. And there is absolutely no coincidence whatsoever that those are both 3s. Okay, so you find the axis of symmetry first using a formula, and then you plug it in to the equation to find the y value of the vertex. And I apologize for my heavy breathing. I'm just having a really hard time breathing. So if I talk for too long at a time, I have to really catch my breath. No, I do not have coronavirus as far as I know. I'm pretty good, but yeah, so just if you hear that a lot, that is why. Okay, anyway, so first thing we're gonna find is if it opens up or down. That is decided by the a value, again, in ax squared plus bx plus c. So again, by the coefficient of x squared. So if a is positive, it opens up. It's a happy parabola, right? It's being positive, yay. If a is negative, it opens down. It's being a negative parabola, and it's frowning, and it's very sad. So again, you only look at that in deciding whether it should open up or down. All right, the next thing, so the axis of symmetry and the vertex, like I said, the axis of symmetry helps you find the vertex. And this is the only part of it that you have to do, math and stuff. So the formula for axis of symmetry is x equals the opposite of b over 2a. And I say opposite with great intention because if you think of it as negative b, you might not realize that you have to plug it in no matter what, and it will become the opposite sign. So if b is negative already, it will become positive b. If it's a positive b, it'll become a negative b. Because when you enter in your b, whatever it happens to be, you put it in parentheses and then you multiply it by -1 afterwards. So if it's positive, it becomes negative. If it's negative, that would mean it would have 2 negatives next to it, become positive. Okay. All right. So again, b is your middle term here. Your middle goes with the middle term, but really it's just the coefficient of x. And then a is your coefficient of x squared. And then once you find that, so you'll get, like I said, your axis of symmetry will always be x equals some sort of number. You take that number and you plug it in everywhere you see x into your equation. And then you simplify this, of course, using order of operations, and you get like y equals a number. So then your x and your y, sorry, my f of x is everywhere. Your x and your y become your vertex. So it's your x value from your axis of symmetry and the y value after you evaluate. Sorry, I keep having to move this. All right, and then the y-intercept is super duper easy. Remember, anything on your y-intercept, or excuse me, like a y-intercept always has a x value of 0 because you're not going anywhere left or right, right? You're staying at the line x equals 0 and then just going up or down. So your y-intercept will always be 0, comma, whatever that c value is, right? So, and again, like that plus or minus c tells you, you know, where to move it up or down. All right. So let's put these to practice, shall we? I forgot I did one-sided copies. So I turned it over. There's nothing there. Okay. Welcome to page 2. So first one, we have y equals 2x squared plus 8x minus 5. And we're going to do this so you can see it, and then I'll graph it in a second. So we're going to find everything here and then put it to work on the graph. So first identify your a, b, and c. A is 2, b is 8, c is -5. All right, so you want to know which way it opens. Well, a is positive, which means that it opens up. So it's going to be a happy parabola. And you don't really like use that to graph anything. It's just kind of to check and see, you know, make sure whether you did it right or not. So if you go through all the rest of this and you find a parabola that's downward facing, you're like, shoot, I don't think I did something right. And if you will recall in that crazy video where I couldn't do simple math, that's exactly how I knew I didn't do it right. Because I knew that it was supposed to be an upward facing parabola. And when I went to graph it, it was downward facing. And so I'm like, oh gosh, what did I do? And then, you know, it took me forever to figure it out. So, so that's why this is like super useful, because you can just see if you did things correctly. Okay, axis of symmetry. So x equals -b over 2a, or opposite of b over 2a. So b is 8 and a is 2. So I have -8 over, remember you got to do this first. You can't do -8 divided by 2 times 2. It'll mess you up. So if you're doing it in your calculator, make sure you do the multiplication of the denominator first. So you have -8 over 4. 8 divided by 4 is 2. So you have -2. Okay, now, so my axis of symmetry is x equals -2. And I can, if I want, I'm going to go over and graph that. So I'm going to go over to x equals -2, which is right here. And that's where my line is going to be drawn through. And again, you either have to dash it, make it a different color, highlight it, do something so that if somebody were to look at that, they know that you're not just graphing the actual line x equals -2 and then also your parabola. They have to know it's not part of the graph. All right, back to this. So remember, I take this x equals -2 and I plug that in for each of these x's. So I'm going to put -2 there and a -2 there. So I can do, if I want to, I can do this by hand, or I can do it in my calculator, and it's totally up to you. But if you're going to do it by hand, you do your exponents first. So negative 2 squared is 4. So you have 2 times 4 plus 8 times negative 2 is negative 16, and then minus 5. 2 times 4, of course, is 8. Plus negative can turn to minus, so minus 16 minus 5. 8 minus 16 is negative 8. Minus 5 is negative 13. And I think I honestly had to do that just to prove that I can, because that's what I messed up on before. So y equals negative 13. So my vertex is the x, sorry, you can't see it, is the x value of the axis of symmetry and the y value. So my vertex is negative 2, negative 13. Okay, so now I'm going to graph that. So I go onto my axis of symmetry. So negative 2, then negative 13 is right here. All right, now to my y-intercept. So remember, my y-intercept is 0, c. It's going to be 0, and then my c value is negative 5. So 0, negative 5. And you're like, well, that doesn't really look like a parabola, so how do I do this? Well, remember, this is the line of symmetry. So on the other side of this, every point on the right side has a mirror image on the left side. And so, like this point right here, your y-intercept, from my axis of symmetry, it's 2 over to the right, right? So 1, 2. So from my axis of symmetry, on the same value of y, I can go 2 to the left and make another point. And now, as best I can, I make this into a parabola. And the skinny ones are hard to make them look like anything but V's. But remember, this is where we made our reindeer. Yay. So, of course, those are not part of the graphs, but they're just happy reindeer. Okay. One more of these. And then I'm hoping that you have enough memory from it to go on and do your own. So we have, well, actually, you know what, let's do number 3, because number 3 doesn't like help you out at all with like the x equals or whatever. So you have to do it all yourself. Okay, so number 3, y equals x squared minus 4x plus 3. A is 1. B is negative 4. C is 3. Which way it opens? Well, A is positive, so it opens up. So it'll be another happy parabola. Your axis of symmetry, so it's x equals opposite of B over to A. Opposite of B, so B is negative 4. So opposite of negative 4 over 2 times A is 1. Negative of negative will be positive 4. 2 times 1 is 2. So it's 4 over 2, which is 2. And then, so let's see, I have x equals 2 for my axis of symmetry. If you want, you can go graph that right now. So x equals 2. And then I take that 2 and I plug it in to my equation to find out what y equals. So y equals, I'm just going to do parentheses squared minus 4 times parentheses plus 3. This is a really good way to remind yourself to plug in that way. Of course, with the positive 2, doesn't matter that much. With negatives, you could really make a difference there. So 2, 2. And just to remind you how to do this in your calculator in case you want to, if you just open up, oops, sorry, you should probably be able to see it, huh? Okay, so open up set of parentheses, and you put 2, parentheses squared. And again, like, you don't, with a positive value, you don't need the parentheses, but the parentheses are just a super good habit, because in case it is negative and you forget the parentheses, then you would have like negative 4 instead of positive 4, because it would, if you didn't have the parentheses, because it would square the 2 and then multiply it by negative 1, whereas if it's in the parentheses, it'll square the entire thing. Okay, so 2 squared minus 4 times 2 plus 3 equals, it was a mystery, you can't see it, negative 1. All right, so that's negative 1. So y equals negative 1. So my vertex is 2, negative 1. So I'm going to graph that. So 2, negative 1 is kind of hard to see because it's like up here. And then y-intercept is 0, c. So that would be 0, 3. All right, so 0, 3 is right here. And then I want my mirror image point, so it's 2 to the left. So I'm going to go 2 to the right. And there is my happy parabola. And for right now, like it doesn't super duper matter exactly that you're, crossing the x-axis at the right point. Those are our solutions. And today we're not finding those, so you don't have to worry about that. Okay, so your optional assignment today is this sheet. And I don't know, I think you have all 6 on there, but certainly do as many as you need to. If you remember this super well and you don't need to do any of them, that's cool. If you need to just do a couple, do however many you need to be good at it when you go to Delta Math. So, because you'll definitely have to find the vertex and the axis of symmetry and vertex algebraically on Delta Math. Okay, so axis of symmetry, let's see, you have y equals x squared plus 6x plus 6. All right. You can decide if you want whether it opens up or down. A is a positive 1. So this one's going to open up. Axis of symmetry is negative b over 2a. So x equals, so my a is, if you want to write this down too, a is 1, b is 6, c is 6. If you don't want to write that down, you don't have to. You can just, obviously just get it from the graph. So x equals negative 6 over 2 times 1. So negative 6 over 2 would give you x equals negative 3. Then you plug into the equation. So y equals negative 3 squared plus 6 times negative 3 plus 6. Again, if you want, go to your calculator. This is where it's hugely important that you put in parentheses because that is a negative. So negative 3 squared plus 6 times negative 3 plus 6. And you should get negative 3. So y equals negative 3. So you will get negative 3, negative 3. And then 0, y-intercept 0, c, so 0, 6. And then you just graph all of this. And, on a couple of these, I think you might have to, like, change your grid, right? So, like, for this second one, if you do that, where you have negative 12 for a y-intercept, you're going to, like, these only go down to 10. So you might want to make this, like, 2, 4, 6, 8, 10, like that. But you don't have to do that on the first one. All right, so x equals negative 3 is my axis symmetry. So 1, 2, 3. I'm going to dash that line. And I have negative 3 for my vertex. 0, 6. 1, 2, 3, 4, 5, 6 for my y-intercept. And then make my mirror image point. So I'm 1, 2, 3 to the right of the axis of symmetry. So I'm going to go 1, 2, 3 to the left. And there you have it. All right, so that's how you do those. Again, those are if you want to. So it's an optional assignment. You certainly don't have to, but it's like I said, it's a good idea to practice if you kind of forget how to do that stuff. All right. Okie dokie. Well, that is it. And next time we talk, we'll be talking transformations. So that'll be lovely. All right. Have a good one.